So to round things out and complete this section 5, we're going to talk about the hyperbola now. And you may or may not be familiar with this curve, but basically it's the set of points, the difference between whose distances from two fixed points is constant. That sounds weird, but you're going to have two fixed points either this way, or it could be this way, or any which way you want. And you're going to have the branches of this curve, there's two of them, branching. In this case, it would look something like this. The shape of those branches depends on, well, the equation itself. So typically an equation looks like this. You're going to have x minus h quantity squared over a squared, but then minus y minus k squared over b squared is equal to 1. And I'll have to say, if the x term, can't read my own writing, that's something I've lived with all my life. Doesn't bother me. The x term is positive, in which case the branches go left and right. They open horizontally as x does, okay, the x-axis. But in the other case, it could be y. So you might have, y minus k quantity squared over a squared, etc. You got x minus h quantity squared over b squared is 1. So when now I have to spell out because people are always asking me this. I know when the y term is positive, it opens up and down like so. Okay, so it's quite an elaborate curve to graph. There's a lot of pieces to it. You got the vertices, which are, by the way, the vertices are the points on the curve that are along this axis of symmetry. There's two of them, and there's two foci, and there are even asymptotes, which are these lines that the curves follow. So we're going to find all that on this example. Ready? Let's do it. So what we have to do in this case, again, is complete the square. It's as if we haven't had enough lessons on this, but here we go. We have 9y squared. I'll bring together the minus 36y. And we also have minus 4x squared minus 8x is equal to 4. We're going to factor out the 9 from the y squareds. That leaves behind 4y, doesn't it? I'll leave a space to complete the square. I'm going to factor out a negative 4 from the x's, so we have x squared plus 2x, leave a space, and over here still that 4. And now we complete the square. Half of 4 is 2 squared is 4. So, but we added not 4, but 36 here. Okay. And then half of 2 is 1 squared is 1. But in this case, we subtracted 4. Interesting. So our equation becomes 9 parentheses y minus 2 squared minus 4 parentheses x plus 1 squared. And on the other side turns out to be 36. When we divide the 36 over, 9 into 36, we end up with y minus 2 squared, a rather benign problem this time, minus, in this case, we have x plus 1 squared. I think we get 9 here, and we've got it in the form we like. The question first comes to mind, which way does it open? Since y is positive, we know it's going to do that. The next question would be, well, where is it centered? Well, you look inside the parentheses and you just don't get them backwards. Go x first, always minus 1 and 2. All right, I think we're good to go. Centered at minus 1, 2. Minus 1, 2 is here. We still look at the numbers under y and under x. Under y we have 4. Square rooted is 2. So we're going to go up 2, put a mark there. I'm not putting a point, and down 2. And for x, the x direction, I'm looking at 9. We're going to go left, right, 3. We're not done. Next, what we do is, in fact, I might do this in red. I'm going to draw a box, okay, that fits these marks. And if you've ever done hyperbolas, you know what I'm going to do next. What's next is I draw diagonals through that box as best I can. What are these? These are the asymptotes. The asymptotes are like any other asymptote. It's a line that your curve tends towards. All right, we're ready to graph it. Since it opens up and down, I'm going to see where I put a line here. I'm actually going to put a point there, and that's a vertex. Okay, that's a vertex. And then I do my best to make it swoosh towards those asymptotes. Down below, I do the same thing. I put a vertex here on the box, swoosh, and I'm not the best at drawing, but there's my hyperbola, and I'm proud of it. So for full credit, what we want to say is, what are the vertices? Okay, the vertices are, and then you can play that game. X looks like it's -1 the whole time. The center is 2, and then you're going to go plus and minus 2. That's fine. We need the foci. The foci are, well, we have some work to be done here. Okay, we got it. Okay, the foci actually, if you know your stuff, what happens with the foci is you have this axis of symmetry running through, and the foci are farther in somewhere. So let's do the work on that. C is equal to the square root, okay, of the two guys added. So we've got 4 and 9. C is the square root of 13, which is, you know, it's between 3 and 4. It's 3 point something. So it's not 2. It's 3 point something up here somewhere. There's a focus. This is a vertex. This is a vertex. And down here somewhere is a focus. All we really have to report out is to say -1 and comma 2 plus minus square root of 13. Did it. Almost done. We want the equation of the asymptotes. That is to say, y equals mx plus b. Okay, but I'm going to be pretty lax on it. I'm going to do it the following way that I learned in some sort of textbook. You take your equation, which is y minus 2 squared over 4, etc., minus x plus 1 squared over 9, set it equal to 0. Not 1, 0. And solve for y. Okay, so we'd say y minus 2 squared over 4 is equal to x plus 1 squared over 9. Maybe I'll cancel, I'll bring that 4 over. Boom, 4. And then I'll square root both sides, and I'll say, you know what? Y minus 2, when I square root both sides, right, is equal to plus or minus square root of 4 is 2, square root of 9 is 3, and then here we have x plus 1. You know what? I'm good. These are the asymptotes. You want to get fancier, you can, and I've done that. Where? Pre-calc. But you can do this because you guys are calculus students, Calc 2 students. So the vertices are there, the foci are there, and there's a way to find both equations. Yeah, and pre-calc, I write it out, and I go, look, it is the same equation. Everything's perfect and wonderful and all that stuff. But yeah, the y-intercept, everything lines up. By setting it equal to 0 and isolating y, and don't forget your plus minus, you've got the equation of the asymptotes. It's a nice little math trick there. So to finish this section off, it's a long section of graphing and talking and all that. It's a condensed section on everything we knew about, almost like a chapter of pre-calculus is this one section. But anyway, let's play this game. So the last thing I assigned to you guys is, can you find the equations of conic sections? And it's probably best to sketch out the information first, and then you go for it. So first of all, you notice it's a parabola. Okay, it's got a focus and a vertex. The first thing I do is I sketch it out, and I go, the focus is 2 and -1, so that's the focus. They said the vertex is 2 and 1, 2, 3, and that's the vertex. And so what do you know about the curve then? I think it's opening like this. It's opening down. So that means I can run over here and go, oh, you might mean it must be of the form 4p y minus k is equal to x minus h squared. But since it's opening down, okay, I can put a negative in front there. Other people handle it in a different way, okay? But anyway, we can figure out this stuff. What we know so far, what we know is minus 4p y minus, we know what the h and k are because of where the vertex is right there. So that tells us that this is 2 and this is 3, We're just about done with this thing. But what we want to goof around with is say 4p is equal to this guy right there. We want to find p. So if you look at the curve, you just go, well, the p is this distance right there. It's the distance between the vertex and the focus. It turns out that p is 4. So therefore, our final answer, if I put in a 4 for p and get negative 16, y minus 3 is equal to quantity x minus 2 quantity squared, happy. Okay. And the last one, okay, pause it, stare at it, right? Where do you get the p? Well, that's why I say sketch the curve and you get the information. I knew the vertex was 2, 3, but I didn't know it opened down until I drew the picture and I go, oh, the focus is below it, so it's opening down. The directrix is up here somewhere, right? And also I know that P stands for the distance between the vertex and the focus, for example. So that helped a lot. Okay, this last one is an ellipse. You know what I'm going to do? I'm going to draw pictures, foci and a vertex. Okay. How many vertices are there on an ellipse? There's 2. But okay, let's draw a picture. The focus is going to be, the foci are at 0, -1, and 8, -1 down here. You know what that tells me is that the thing goes like that. Because they're always along the major axis. Okay? And furthermore, the vertex is 9, -1. So out here, pretend that's 9. Yeah, if this 9, -1 is a vertex, this is a focus, this is a focus. Well, okay, great. Our equation looks like this. It's going to be x minus h squared over something squared plus y minus k squared over something squared is equal to 1. The h and the k is the center, okay, the center of your ellipse. And that's going to be right between the foci. Right between, if this is 0, -1, and this is 8, -1, I can guess that this is 4, -1. So now we've got some information. We can come along and go, okay, so x minus squared over plus y minus squared over equals 1. Okay? But we know these guys now. H is 4 and y is -1, so this actually becomes +1 there. Almost done. We just have to figure out A and B and C and all. We just have to figure out A and B. Okay? You know, you can do it in different ways, but what we have, for me, the fastest way is to simply go, this distance here is A. Okay? A is from 4 to 9. I get A is 5. And the focal distance from 4 to the focus, 8, I get C is 4. Okay? Man, we got this. I'll put 25 here, and then I have to figure out B. B is the square root of the big boy, 25, minus the little guys. On an ellipse, that's what happens. You get square root of 9, so you get 3 squared. So you get 3, so 3 squared is 9. There's your equation of the ellipse. Okay, so the picture for me is worth 1,000 words. Okay, as far as I'm concerned, that's what's important. And that's it for 10.5. We still have to look at parametric and polar stuff, so that's coming up. I'll see you there.